All right, guys and gals, thank you for having your notes sheets out. Please make sure you have the one that says multiplying decimals at the top. All right, so we're going to work on multiplying decimals. That's our goal for today. In order to do that, we're going to use a model called an area model. Have you guys heard of area models before? No. Cool. Probably like when you were in, I don't know, what do you think? Fourth, fifth, third. I love area models so much. And an area model is a useful tool for developing an understanding of decimal multiplication. Not just decimal multiplication, but lots of types of multiplication. It can be an efficient method for finding a product involving simple decimals. We have the word product, this vocabulary word right here. Product is the fancy math vocabulary word for an answer to a multiplication problem. Just like sum is the answer to an addition problem, I'm going to ask that you're on this page with me. We haven't moved ahead. Sum is the answer to an addition problem, and difference is the answer to a subtraction problem. So the traditional multiplication algorithm, here's a fancy word, is the most efficient method for finding a product involving multi-digit decimals. So if we look right here, this is an algorithm. I'm going to make sure I spell this right. That's an algorithm, but we're going to talk about why that works. So you're going to see 3 different strategies today. Okay, so right here, we have an area model. And in the area model below, 1/10 of the grid is shaded horizontally. Okay, horizontally is the part in green. And 1/10 of the grid is shaded vertically. So vertically is the part that's in fuchsia, with 1 square in the overlapping region. I want you guys to take your pencils, and where it has this multiplication sign, I want you to draw an arrow, and I want you to write the word of. So right now we have an example of 1/10 times 1/10. We can also think of that as 1/10 of 1/10. Okay, we're finding a part of a part. So right here, we have 1/10 of this whole grid. There's 100 of them. 1/10 in green. And if we find 1/10 of that, that gives us 1/100, or 1/100 over here. Notice how I'm not saying like 0.1 times 0.1 equals 0.01. I'm saying 1/10 times 1/10 equals 100. So it's really important that we use that precise place value language there. All right, let's look at the second one. It says in the area model below, 3/10 of the grid is shaded horizontally. So that's the part in green. Okay, we have 3 out of 10, 3/10. Vertically, we have 4/10 right here. Okay, so vertically would be those 4/10 there. They overlap 12 squares, so that gives us 12 over 100, 12 out of 100, which we can write as a decimal like this. Okay, I'm writing additional things on my notes. You can do that too. Okay, once again, we have 3/10 of 4/10. So that's a really great area model that helps us see why this works. We're finding a part of something. All right, we're going to look again, but now this is a distributive property area model. And this is just the beginning of us talking about this a ton this year, and then you're going to talk about it even more when you're in 8th grade and even more when you're in algebra. So we have 6 and 5/10 times 2, or 2 times 6 and 5/10. We can say it either way. Multiplication is commutative, so we can switch around the order. Notice how we decided to write it this way down here. Okay, we decided to write it with the 6 and 5/10 on top, just because that's how we're more familiar with an algorithm. So we did 2 times 5 is 10, so we're going to carry that 1, put the 0 here. 2 times 6 is 12, plus 1 gives us 13. Now we had 1 digit behind the decimal point. So we're going to move over our decimal point here, and we're going to get 13. Now that also makes the most sense, because if we're just estimating, 6 times 2 is 12. So an answer around 12 is going to make the most sense. It wouldn't make sense to put the decimal point between the 1 and the 3, because that would be 1 and 3 tenths. It wouldn't make sense to leave the decimal point here, because that would be 130, and none of those would make sense. So 13 is the answer that makes the most sense. Now let's stretch our brains just a little bit, and let's look at it with an area model. Do you guys see this right here? Okay. Take a minute, and will you talk to the person next to you about how you notice that area model is set up? You can do that right now. So here are a couple of things that I heard you guys say. If we look at this, we have 2 times 6.5, or 6.5, or 6 and 5/10. So we're going to do 2 times 6, and we get 12. Think of this as this side is 2, and this side is 6. Then we have 2 times 5/10, and that's going to give us 1 whole there. Okay, so 12 plus 1 is 13. There's our answer for that. When we took 6 and 5/10, we split it up into the ones place and the tenths place. If we had more numbers, we might split it up into the hundredths, the tens, the ones, and the tenths place. And that would be a lot, but we could definitely do that. So this one down here, our last one on this page, there's a lot more going on here. Talk to the people next to you. What do you notice about that last one? Go for it. Looking at this last problem here, we have 4 and 3/10 times 3 and 2/10. We took that 4 and 3/10 and divided up into the ones place and the tenths place. Same thing with the 3 and 2/10. We have the ones place and the tenths place. All right. So if we multiply 3 times 4, what do we get, everybody? 12. Thank you for your help. Okay, 3 times 4. I'm kind of thinking of the length of the edges to do that. Then we have 3 times 3/10, and that gets just a little bit tricky. So we have 3 times 3/10. Well, we know 3 times 3 is 9, right? We have this, we moved our decimal over, okay? So now we're going to have 9/10. So that's why this right here is 9/10 and it's not 9. Same thing here with 4 times 2/10. Well, 4 times 2 is 8. So 4 times 2/10 would be 8/10 there. And then the last one here, and I want you to listen very carefully to this, because this is a very common mistake. We have 2/10 times 3/10. Okay? And I'm going to add just a little bit of room here so we can talk about that. If I have 2 times 3, what's that, everybody? 6, okay? Okay, we're good in good shape. But it's 2/10 times 3/10, which means that I'm going to need to move over my decimal point 2 places, which puts me at 6/10. And that's a big deal, and that you're going to need to know that for the next page. All right, will you please turn to the next page there? All right, so up here, here is the really, really big thing. If you have a pencil, you have to circle this. It says when a problem has several digits, the traditional algorithm is practical. It is also helpful to estimate, circle that with your pencil, please, to estimate your answer. You should always estimate before you get started. Remember how we did that on the previous page with 6 and 5/10 times 2? So we think about not only how we would move our decimal point, but also what would be a good solid answer. What answer would make the most sense in that situation? Okay? So what I'm going to ask you guys to do